Welcome back to Robominions.in AI interview preparation app. The topic of this video is counting both degree 1 and degree 2 nodes in binary tree. Okay. So before tracing this part of the code, I request you to watch this video on a laptop or a bigger screen so that you can trace the code along with me. If you're watching it on the phone, please make it as a full size horizontal screen and watch it properly so that you can trace the code along with me. And you have to install the Robominions.in AI interview preparation app on your laptop so that after watching this video you have understood the concept, but after few days, like 10-15 days, you tend to forget all these important concepts. So for revision purpose, you can revise this in a span of 2-3 minutes using just back and next button. So there are hundreds and hundreds of computer science concepts which you can't remember at any given time. So what you can do is you need to have a mental mapping. This app will provide a mental map of all the codes, and it provides the control to you with a click of back and next button. Okay. So yeah, to download this app, visit the website robominions.in and download latest version of the app. It's a laptop based or a desktop interview preparation app. Let's continue to our main code. Uh, Tracing the code, counting degree 1 or degree 2 nodes in binary tree. So let me start. So please remember, this arrow will be tracing the code execution lines. So wherever the execution is happening, so arrow will point at that specific line. So we have hash include stdi.h, then stdlib.h included. Then we have hash include binary tree create.h. So binary tree create.h header file is included. This header file has the create binary tree function, which will give default values to the binary tree and creates the binary tree for us. This part of the code has already been explained in the video DSA49 create binary tree. Please watch that video if you haven't yet watched, and then come back to this video. So let's start tracing the code again. Then we have int main. Now you can see create binary tree function in the header file binary tree create.h has created your default valued binary tree. It has given you the binary tree. The root pointer here, node star root, is pointing to the root node. Okay. Now we have to count the degree 1 or degree 2 nodes in the binary tree. So if we have to count all the degree 1 or degree 2 nodes in the binary tree. Let's go to the function count degree 1 or degree 2 node function. We pass the root pointer. So right now it's pointing our main target node is right now this one. So it goes to that goes to the recursively called function. We have left count equal to 0, right count equal to 0, iteration not equal to null. This node is right now not equal to null. That is true. Okay. So the address hash 100 was passed to this node pointer ITR. So it checks ITR checks ITR has the value hash 100. So ITR is not equal to null is true. Left count equal to, now we have recursively called the function and sending ITR of left. ITR of left is hash 200. So that is the address. Hash 200 is the node address of this one, this node. So now target node is this one. So now again function is called recursively. It goes back to there. Now our target function target node is this one. So again left count equal to 0, right count equal to 0. ITR not equal to null. This node is not equal to null. It's true. Goes to the left count. Now again ITR left. ITR left is hash 400. Again hash 400 node is called. So now we have this is our target node. So again recursively count degree 1 or degree 2 node is called. Left count equal to 0, right count equal to 0. Now again ITR not equal to null. This node not equal to null is true. It goes again left count, again ITR left. ITR left now is null. So we have again called the count degree 1 or degree 2 node function, and we have null here. Now int left count equal to 0, int right count equal to 0. Now we have null not equal to null is false for this node. That will return 0. So it has returned 0 for this node. So null not equal to null is false. It has returned 0. So left count equal to 0. Now right count, so because left child is null, so that is why it is 0. Now right child, itr right is also null, so null is passed to the function. So null is passed. Now we have left count equal to 0, right count equal to 0, itr not equal to null. So this null is not equal to null is false. It doesn't go inside the if condition, that returns 0. So now both left count equal to 0, right count equal to 0 for this node. Now we come to the if condition. We have itr left, it doesn't have any child. Itr right is also childless. So 0 or 0 is false. Comes to the else part. Left count was, you can see, remember left count was 0 for this, right count was 0. So 0 plus 0 is returned back to the function call of this node. So it goes to the left count of this node. So you can see as it is not a degree 1 or degree 2 node, this node has been marked red. After checking both the child, we saw that it is childless, so it has been marked red. Now we go next step. Now we are again back to here. Now we go to the right side, right child. So when I click next, it has gone to the right side. So now that is because we had itr right. Itr right is hash 500. So hash 500 is the node address of this node. So when you function, we have again function call, left count equal to 0, right count equal to 0, itr not equal to null. So this node is a valid node. It is not equal to null. That is true. Then left count, we have again itr left. So itr left of this node is null. So the function has received null. Left count equal to 0, right count equal to 0. Null not equal to null is false. It returns 0. So left count is 0 for this node. Then we go to the right side, checking the null, checking the right child. So itr right. So itr right is also null. So that is sent count degree 1 or degree 2 node. Left count equal to 0, right count equal to 0. itr not equal to null. Null not equal to null is false. So even that is returned 0. So now we have left count 0, right count 0 for this node, that is node with the data value 14. Okay. Now when you go to the if condition, you check whether there is a child on the left side or a child on the right side. Both sides are childless. There is no child. So 0 or 0 is false. So it goes to the else part. It returns left count plus right count. For this node, left count equal to 0, right count equal to 0. So that is returned. So returned back to this node. So it has as it is childless, it is not degree 1 or degree 2 node. It has marked red. You can see it has been marked red. Now the control has gone back to this node. Okay. Now it checks. Now this node has a left child and a right child. Both the child are there. So the if condition has passed. Now it goes inside. Left count for this left count in the left side is 0. Right count on the right side is also 0. So 0 plus 0, but the node itself is a degree 2 node. So we add 1 here. You can see we have added 1. So this will be turned green now. And this count, so in the total left side count is 1, is passed to the main node, that is root node. So you can see when I do next, it has turned green and the left count equal to 1 has been passed to this node. So the recursive function of this node. So the recursive call on the left side has ended. Now we start the recursive call of function to the right side. When I click next, you can see it has gone to this node now because we have itr right. So right now itr was this, itr right is hash 300, that is this node. Okay. So recursive call is done again now. Recursive call is done. Left count equal to 0, right count equal to 0. itr not equal to null. This node is not equal to null. It is true. Now left count equal to, again the recursive call of function, but you have itr left. So left is, for this node, itr left is hash 600. So it goes to this node now, hash 600. So hash 600 is passed. Then hash 600 is the address. Please remember, I'm following this convention. So always remember this convention. Okay, int left count equal to 0, right count equal to 0, itr not equal to null. This node is a valid node, it is not equal to null, it is true, it goes inside the if condition. Now when we call the function again recursively, itr left, so itr left is null. You can see itr left is null for this node. So when you go to the int count degree1 or degree2 node, it has null here. Then it left count equal to 0, right count equal to 0. Null not equal to null is false. It comes out of the, it doesn't go inside the if condition, it returns 0. So 0 has been returned to left count for this node, the node with the data value 15. Now we check the right side. Next we check the right. itr right is also, itr right is null. So null is passed for this function call. So it goes to the function call. Again itr null not equal to null, false, returns 0. So 0 is returned. Now both left count is 0, right count is 0 for this node. So when it goes to the if condition, for while checking the if condition, it doesn't have left child, it doesn't have right child. 0 or 0 is false. Comes to the else part, it returns left count 0, right count 0. Now as there is no degree 1, it is not degree 1 or degree 2, this turns red. So it's not a valid node, right? So it turns red and the control is returned back to this node now. Okay, so now in this node we check we have finished the left side. Now we have to see the right side. So now when I click next, it goes to the right side. You can see, because we have itr right is hash 700. That is the reason it goes to this. So this node address is passed to the function. So when it receives, it goes, it checks itr not equal to null, true, itr is not equal to null. Then it checks the left count. Okay, now left count of the, left, itr left. So to calculate the left count, we have itr left is null. So null is passed to the function. So again null is passed, null not equal to null is false, that returns 0. So left is done, left side is null for this node. Now we check the right side. Right, itr right is null. So itr right is null, it goes, null not equal to null is false, that returns 0. Okay, now both left count is 0, right count is 0. Now it checks the if condition whether there is a child. There is no child here, there is no child here. So 0 or 0 is false. Okay, it comes to the else part, it returns the left count plus right count. So 0 plus 0 is 0, because this is a degree, it is not a degree 1 or a degree 2 node. There are no child, right? So it sends 0 plus 0. So that is returned back to this node as a right count. So when I click next, you see it has been returned. So now right count is 0 for this node. And when we do if condition for this node, it has both left and a right child. But when it returns, so it goes inside the if condition. And for this node, we have left count and right count. So left count is 0, right count is 0, and we add 1. 1 because this node itself is a degree 2 node. This node itself is a degree 2 node, and it returns that count to the right count of the main node. So now main node, left count is 1, right count has turned 1. Now we check the if condition whether this node itself is a degree 1 or degree 2. As it has both child, it is a degree 2 node, so it comes inside the if condition. So we do left count plus right count plus 1, because we count the node itself. So we got 3. 3 is like, so when we click next, so you can see count of degree 1 or degree 2 nodes in the tree is 3. There are no degree 1 nodes, but there are degree 2 nodes, right? So there are 3 degree 2 nodes, so that is counted. So rest of the nodes are turned red because these are childless nodes, so they don't have any degree. Okay, so then we return from the main function, and the time complexity is order of n, as we are going through each of the nodes. That is why it is order of n. Okay, if you want to access the code of this algorithm, you can click on the code button in the app Robominions.in AI interview preparation app. Click on the code button and you can use the code. run it on any online or offline compilers. And don't forget to download the app. You can trace the code with individual step. If, after watching, you can't keep watching like hours of videos before going to an interview or a gate exam. You have a lot constrained time for preparation, so you need to revise your concept in a very short span of time. So this app will help you with just a click of a back and next button. You can quickly revise and go through the code and understand the concept. Okay, so the idea of this app is to make your revision very quick. Signing up, Dhananjai Sharma,
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app, and make your coding easy. Thank you for watching this video. Bye.